Today we're going to be talking about the March Reactive Ion Etcher, or RIE. The RIE uses a plasma to etch all sorts of materials. Take 4 different kinds of gases. We got this one. We've got hydrogen, oxygen, CHF3, those 3 fluorine atoms, and CF4, carbon tetrafluoride. By changing the gases you're using, you can etch different materials. This includes silicon dioxide, silicon nitride, silicon, and organics like photoresist. It's widely used for a descum step after you do photolithography, and you want to clean out the bottom of your features and make sure you're all the way down to the substrate. Today I'm doing some maintenance on this guy. Apparently one of the mass flow controllers calibration has wandered, and sounds like there's a good chance that one of the O-rings, specifically the O-ring in this little window here in the chamber, may have gone south. It's consumable since it's running oxygen plasmas through there. Oxygen plasmas are, of course, great at etching carbon atoms, turning them into CO2. I'm going to do some diagnostics on this, and I'll show you a little bit about how this works. So but first, turn it on, power to the main control system. First I have to log into FOM, which is our facilities online management software. Okay, so now I'm logged into FOM. Let me go ahead and turn this guy on. Main controller comes on. Power supply. There's a little breaker back here, power up here, vacuum pump and chiller, and that's all there is to it. It's a pretty simple tool, it's pretty straightforward to use. Okay, so now I'll go into manual mode and show you what's back here. Well, first of all, here's sort of our standard recipes: descum, silicon dioxide etch, silicon nitride, titanium, I forgot to mention that, and of course photoresist. Each different recipes. There's a switch for the pump and the chiller. Show you around the back. There's a big old Part1 mechanical pump and the chiller. Let's see. Here are the gases that it takes. Going up there. Let's see, we got oxygen. We used to have sulfur hexafluoride going here. This one is CF4 or CHF3. One of them, there's the other one. Polycarbon 23. Yeah, what else? So the chiller is used to cool the platinum. We'll open it up to show you what the inside looks like. This big old pump's got formalin in it, because all the sort of nasty reactive gases that can come out of there. Okay, now I'm going to open this guy up and show you what it looks like on the inside. To do that, press this bleed switch. What that's going to do is it's going to pump down the chamber. This is pressure and millitorr. Once it gets below some set point, it's like 100 millitorr, it'll go ahead and close the pressure sensor valve, because it's not supposed to be exposed to atmosphere. Then it starts pumping nitrogen in there, and we're good. Okay. So here's the reactor. There's the top. I think it's called the clamshell reactor. This I think is the anode, and everything else serves as the cathode. So what happens is you put your wafer on there, you pull RF plasma, and the negative charge accumulates on or around the wafer, and it pulls those positive ions through there, through that potential, and they bombard the wafer. Alright, so I guess the first thing I should do to see how this thing is behaving. So I think I'll go ahead and close it back up, see what kind of base vacuum we get to, and check the mass flow controllers. So I closed it up, I pressed manual operation and vacuum. Now I'm going to turn on the pressure sensor. Let's check our pressure. Uh-oh. Better turn it off. This tool is also about 20 years old. So some of the features don't work so well anymore. But it's limping along, and it's a pretty often used tool in the clean room. Alright, let's see what that pressure is. There it is. Coming down. That seems pretty good. Alright. Wow, that's really good. I think somebody may have come through and already repaired this. I don't see a problem with the base pressure. Alright, let's see. Let's check this. Those are the set points for the various mass flow controllers. There's only 4, even though there's room for 5. Alright, let's see. Go ahead and read them. 0, 0. There's the problem child. Gas number 3, which is CHF3. Okay. Gas 4 is 0. I don't know. Looks like everything's okay. Other than that mass flow being not correct. Well, now it's up to 5. So one of the other engineers reported that even when you close the valve in the back for this gas line, it still reads 5. So it doesn't seem to be leaking. It does really appear to be a calibration issue. Alright, guess I'll do a couple more diagnostics and see what I can learn about zeroing these meters out. Okay, so I got a little plasma going in there. See, it's not going to be hard to see, but it's purple because there's a bunch of nitrogen in there. There it is off. Trying to turn it on, but the pressure's too low. It's hard to see, isn't it? Anyway. So what I've done is I've turned gas 3 all the way up. I got it set. Going back to gas 3. I got it set to 100% open, the mass flow controller. I'm just purging that line of gas. So you can see, it may not be obvious, but this is gas. Gas is on. This is my set point. This is the current flow rate, 5, which is essentially 0. Current pressure is 45. Just to show you, let's see, let's play some games here. So, let's put in some oxygen. Currently set to 0% of full scale. So I'm going to go ahead and put 10% of full scale, which I think is about 250 SCCM calibrated to nitrogen. You can see our pressure starting to come up. 182 millitorr right now. Got no plasma on. No plasma. Maybe it would be better to actually turn the lights on for this. Yeah, hold on. Okay, so I turned the lights out. Gives a little better contrast for the camera. Okay, so I got 10% of gas 2, which is oxygen. I'll show you what the different colors of gas plasmas are. Here's my RF power supply. It's not on yet. 13 megahertz, 13.56 I think megahertz. Alright, so no plasma. Turn RF on. There it is. Up. Uh-oh. We got a lot of reflective power. Oh, the tuning network caught up. Okay. We got purple. We got a purple plasma. That's not actually good. This is oxygen. It's supposed to be oxygen. Should be blue. Let me turn this flow rate up a little bit. The color of the plasma changing a little bit, maybe. Still purplish. Not great. Must be a nice baby blue. No. Might be a problem. Almost 250 millitorr, 20% of full scale, 300 watts of forward power, only 5 watts are reflected. So let's see what happens when we add some CF4. Let's see what color that turns. And we'll leave the oxygen plasma in there. So I'm going to go ahead and increase the reading to about 10%. Let's see what we get. Pressure's come up a little bit. It's always purple. Odd. Huh. Reflective power's come up a little bit. It's not terrible. Each gas has its own characteristic viscosity and calibration constant for the mass flow controllers. What we're reading here is percent of full scale, and it's not calibrated for each gas. Shown here. So I'm going to go ahead and increase the amount. Of CF4. The CF4 is used a lot for etching plasma, or etching silicon nitride. Still pretty purplish. Pressure's come up. Reflected power is not bad. There we go. Got some focus. Pressure's at 338. Huh. I really don't think the oxygen should have any purple in it. It's a bit disturbing. Let me go through and check these again. Oh, so according to this, when you get to the bottom of the list, it'll show which gases have a non-zero set point. So hopefully that's in focus. Okay, so let's see. So gas 2 is oxygen, 20%. This gas, 100%. All right, let's turn this off. see if, I should say, gas 3 I turned off in the chase behind the tool. Let's see, so our pressure's coming down. Wait a minute. It wasn't. Plasma color hasn't changed. It's kind of purplish. A little tricky to get the true color on the camera. Plasma collected power still 5%. That's good. Okay. So gas 2 should be 0%. Gas 3, 25%. I'm going to go ahead and turn the oh, that's gas 4, which is CF4. I'm going to go ahead and turn that off as well. See, my pressure set point is 0, so that's good. On this particular tool, when the flow rate of the process gases are not high enough to reach the pressure set point, it injects nitrogen downstream of the chamber, but between the chamber and the 4-line pump, or the roughing pump. This only has a roughing pump, so it makes the pump less efficient. So when you inject nitrogen, sometimes it will turn very purple and affect the process chamber. So anyway, let's see. What am I doing here? 0? Yeah, so the only gas I've got going is oxygen. And the color's not right. What's up with that? Alright, I'm going to try and increase the flow rate of oxygen. Plasma is still pretty purple. And that's not good. Why is the plasma purple? Because we don't have oxygen going in. Huh. So, maybe we do have a leak somewhere. But the base pressure was good. I think I'll go ahead and run the oxygen clean recipe and just see if anything, if I've missed something or done something wrong. Okay. Let's see, oxygen clean recipe. So I'm gonna go ahead and turn off the plasma. Plasma on, plasma off. Alright, so turn the gas off. Gas. Air pressure should plummet. Okay, according to our handy dandy sheet over here, recipe 1 is for descom, so I'm going to go ahead and run recipe 1, or program 1. Nobody uses 0? Oh, okay, there is no 0. Anyway, alright, so let's check out the parameters on program 1. So, 0 gas 1, 20 gas 2. This is basically what I was just running. Set, so when I press this is set. Power set to 300. Endpoint 100, that's for an endpoint detector that we don't actually have. Process time 90 seconds. Temperature not used. Auxiliary is the base pressure that it's got to get to before it starts the program. And the set point pressure is 300 millitorr. Alright, so I think we can go ahead and start it. So the vacuum is on. Vacuum valve has opened. The pressure sensor, I think it's a Baritron, has not opened yet. There it goes. Let's see what the real pressure is. 46, 45, okay. There goes gas 2. Oh. It does kind of look like there's a leak somewhere. Or well, we'll see for sure after this. Just going to run the gas for a little bit and try and get to the set point pressure. Yep. So you just injected nitrogen. I'll probably inject some more nitrogen. Or may just go ahead and turn the plasma on at this point. I don't know. There it goes. A bit more. Probably the plasma will come on. There's the plasma. And it's still purple as all get out. I don't know if you can see that. That is not good, dude. That is not good. NASA, we have a problem. Alright. So, I guess I'll go make sure that we're not like out of oxygen. Just double check the oxygen lines. And then I'm gonna, I think I'll go ahead and characterize the leak up rate. And so that if I find a leak, I know when I fix it. Based on leak up rate, and that's a good parameter to have on any vacuum chamber. So, all right. So I buttoned up the vacuum chamber again. I'll go ahead and do a leak up rate test. I'll let it go to I guess about 70, and see how quickly it leaks back up. It's going down to 50 pretty easily, which is a little bit confusing. If I'm getting nitrogen in there, then it seems like I'd have a leak, and that's a pretty good base pressure for a chamber that's got a leak. Alright. Once it gets to 70, I will start a timer, turn off the pump and start a timer. So I'm going to turn off the vacuum, and so that doesn't turn off the pump, it just isolates the chamber with a valve. And then once it gets back up to 70, then we'll start the stopwatch. Okay, and we're off. Let's see how long it takes to get to 100. Okay, 6 seconds to get to 100.